So welcome to all of you on video based IT training. In this video I'm going to introduce DHCP and configuration of DHCP on Cisco router. So every device in the network require an IP address to communicate in the network. IP address internet protocol is a logical address that should be on each device that require to communicate on the network. Without having a proper IP address, no device can communicate on the network. So means IP address is the prime requirement nowadays to communicate on the network. So there are two methods to assign IP address on any device. That can be the static IP, that can be the dynamic IP. As you can see in this picture, like on a machine, on a computer, window-based computer, we have two options here. Either obtain the IP address automatically or use the following IP address. You can see here. So in a small network, suppose we have only 10-20 machines, so very easy for administrator to manage, to configure the IP address statically. But when we have an enterprise environment, we have 100,000 of devices. So it becomes very difficult for administrator to assign the IP address automatically. So the best way, obtain the IP address automatically. But how automatically? From where it will take the IP? For that purpose we require DHCP, Dynamic Host Configuration Protocol. Okay, so DHCP basically is service that permit the network administrator to set up a server to allocate and manage the IP addresses for the workstations and for the desktop computer and other client machine that don't require a fixed IP address. Like maximum time our servers, that even the DHCP server, DNS server, file, print server, mail server, web server, these all servers should be on the fixed IP or static IP. But maximum the client machine does not require a fixed IP. So in this case, administrator can configure a DHCP server. So DHCP can also supply important IP configuration data for the client machine. For example, it's including IP address, subnet mask also, gateway also, and even the DNS and other information where needed and appropriately we require that. Okay, so there are a lot of benefits of using the DHCP. DHCP really reduce the complexity and amount of administrative tasks by using the IP address automatic configurations. If we compare automatic IP configurations and manual IP configurations, so in automatic IP address are supplied automatically. No need to keep moving around different devices, computers, printers to set up the IP address manually. But in manual, administrator should keep moving from one machine to another machine once to set up the IP static IP address. Second benefit, correct configuration is ensured. Whatever information we have configured on the DHCP server, that configuration goes to the client machines. So it ensured that every time whatever the DHCP is assigning to the configuration of the client machine, that is correct. But in the manual configuration, keep moving from here to there, sometimes it can be entered incorrectly. Client configuration is updated automatically. In the next planning we are going to change our IP series or something, and we are going to change DNS server or default gateway. So only updating on the DHCP server, it automatically get updated on the client machines. But in case of manual, it can be a big issue and can cause a lot of network issues to communicate. So if there is some problem in the network, a common source of network problem is eliminated. By sitting on a single DHCP server, we can resolve maximum number of IPs problem or IP configuration problem in the network. But in manual, frequent computer moves increase the administrative phase. Some computer coming inside the network or older computer going outside the network, so it really increase the efforts. So you can say DHCP has a lot of benefit as compared to the manual IP configuration, and really reduce a lot of administrative tasks. So what are the basic process behind the DHCP? To assign the IP address automatically from server to client. There should be some process now, because in this case, look here, if you look on this pic, we just obtain the IP address automatically. But how does client machine get it know on which machine we have configured this DHCP server? So how does it get it know? What is the process behind that? That without configuring any information about the DHCP server, the client machine, still our client machine is able to take the IP. That process is known as DORA process. Correct? So what is basically DORA? DORA stand for D stand for discovery, offer for O, offer O, request R, and A acknowledgement. Correct? So full form of DORA is discovery, offer, request, and acknowledgement. Request done by the client side, offer given by the server, again request done by the client, and acknowledgement given by the server. So for the technical perspective, DHCP works on the port number 67 and 68. Port number 67 is used as a destination port for the server, and port number 68 is used by DHCP server for the client machine to listen. Okay, and 68 port number for listening the client machines. So if we see some simulation, suppose I have configured this one as a DHCP server somewhere in the network. Okay, sorry, this is a DHCP server, and these all are the some of the new clients that come inside the network. So how the process happens? Very first, discovery process means client machine generate a broadcast message to the entire network. This is my MAC address, I need a IP address. Because we don't do any of the configuration on the client machine for the DHCP server, so client machine start the broadcasting, and that is known as the DHCP discovery, very first step. So it's send a broadcast message to the entire network. So this packet, this message reach because of broadcast, so it reached to all the clients from here to here. Here it also goes to here, it also goes to here, one to all. So this is the very first step in the DHCP process, D discovery. Again, second step, this message has reached to all the client machines, so offer given by the DHCP server. Yes, I can give you this particular IP. So offer given by the server side. Again, client send a request. Yes, please send me assign this IP address. And last step, when this server receive the request, it check its entire database again for any type of conflict, any type of problem, and again it send acknowledgement to the client. Okay, So these are the 4 steps: offer, discovery, offer, request and acknowledgement. So these are the 4 basic process behind the DHCP, how DHCP server assign an IP address to a client machine. Correct? So interesting. So DHCP server, as you see in this picture, can manage one or more IP addresses, which may be called as a DHCP address pool. So not only single IP series, single IP servers can manage multiple IP series. If considered as a range of available addresses from which address may be allocated to the client machine, when this particular obtain the IP address automatically configuration is done on any of the client. So when TCP is configured on a client machine to obtain the IP address automatically, you can see here, if we configure this particular option on the client machine, then option button is only necessary to set up elements. Remain everything is done automatically. Okay, so we have discussed about the DORA, what is the basic process behind the DORA, and what is the benefits of configuring the DHCP server. So let's see how we can configure DHCP server on a. So for that purpose, I'm going to use packet tracer and show you the configuration, how we can configure DHCP server on a Cisco router. So I'm going to design very basic topology for that. Okay, 4 machine is sufficient. Hope everybody is comfortable to work on the packet tracer. So connect it. Just going to set up a local LAN. Okay, done. So suppose for example I'm going to configure 192.168.0.0 IP series here. So very first come on the router, enable the interface as normally we keep doing it in the previous videos also. So very first need to configure this particular interface with the same IP series. So it's fast Ethernet 0/0. So go to interface, fast Ethernet 0/0, as we have decided to configure 192.168.0.0 IP series. So IP address means should be option 192.168.0.1 with default subnet gate 255.255.255.0 and no shut. Done. Basic configuration is done. Now we can see on the client machines desktop IP configuration, static IP configuration, so DHCP waiting failed because we don't have any of the DHCP server in the network till yet. We don't configure any of the Microsoft based client DHCP server, Linux based or Cisco based. So come on the Cisco router, let's configure it as a DHCP server. So very first step to configure the DHCP server, to enable the DHCP service on this router. For that purpose, configure terminal IP DHCP pool. This is a basic command to enable the service. Now we can give any name to this pool. Suppose I am giving marketing. So this is the very first command to enable DHCP service on a router. Second command, what network IPs, what I want to assign in the to the client machine. Network. So 192.168.0.0 with subnet mask 255.255.255.0. Done. Simple. Now we can verify. By these two commands, basic IP configuration has been done. So you can see, oh wow, it's 2. DHCP request successful. Check on another machines. DHCP 3. Very good. Means DHCP start working on the Cisco router. Now we need not to keep moving on all the machines again and again to configure the IP. But you can see here right now it is only configuring IP address and subnet mask. We also need to configure default gateway if we have to communicate in different network, and DNS server also. Come back on this. So as we have configured this particular interface 192.168.0.1 on this interface, so naturally this particular IP on this interface will work as a default gateway for all the network, all the device in the network. So command for that is default router 192.168.0.1. Now configure, confirm it. Can we have? Yes. Now start assigning default gateway also. Very good. Check on all the machine. Good. It also start assigning default gateway. Similar configuration for the DNS-server. There can be any server. Suppose I have configured some server, DNS server in my network with IP 192.168.0.2 is working as a DNS server. Check it again. Good. Now it's also start assigning all the configuration, all the parameters that we have configured on the DHCP server. You can verify it. Check on another machines also. Static DHCP. Very good. On this machine also you can see here with different IP, what with same default gateway and same DNS server. Check on all other machines. Excellent. We are getting that. 4 IP series. Sorry, 4 IP address with the same IP series. DHCP. Excellent. You can see, you can verify it, that now DHCP is assigning different IP to different machines with same network IP, subnet mask, and default gateway and DNS server. So whatever configuration, whatever parameter we set on the DHCP server, it automatically start assigning to client machines. So this is a basic configuration of the Cisco routers to work as a DHCP server. One more thing we can add, because as we have added complete IP series 192.168.0.0 to be assigned to the client machines. Suppose we have some of the server in the network that has been configured statically. That can be file server. Suppose for example I am taking file server, or you can say it is my mail server, or you can say it is DNS XYZ. Let me connect these machines also. And these machines, naturally all the server, mail server, file server, our DNS server, server always work with a static IP, and this server is already configured with 192.168.0.2, 192.168.0.3, 192.168.0.4. Put it here because I have given this one. Okay. So, but DNS does not know about this, that these IPs has been already configured statically somewhere. So what I want to say to router, okay, you have this IP series 192.168.0.0, but still you have not assigned IPs from 192.168.0. up to 10. We are not authorized to do that. So what I can do, that IP DHCP exclude means DHCP server should not assign IP from 192.168.0.1 to 192.168.0.10. means up to 10 DHCP server cannot assign the IP to the client machines. After 10 to all the IPs it can assign. Check it again. We have exclude the IP range from this entire IP series 0.0. We have excluded it this 1 to 10. Initially you can see here what IP it was assigning 2, but it's already assigned. Suppose somewhere it is already assigned 3. So if we reset it, because we have excluded the IP up to 10, now what IP series it assigned? Oh wow, it's assigned the 11. Good. So we have excluded IP range. So now we can use this IP is up to for the servers or configuring as a static IP. So in this way DHCP really make very easy for the administrator to manage the IP address. So this is a basic configuration on the Cisco router, how we can configure a Cisco router as a DHCP server. So we have done that. Hope everybody understand how to configure a Cisco router as a DHCP server. Renewal process. What about the renewal process? It keeps sending. As soon as the 50% of the lease time has been expired, client machine again start to renew the process, because every IP assigned by the DHCP to a client machine have a specific lease time. After that time, client needs to be contact to the DHCP server for the renewal. If the client machine fail to renew its lease after the 50% of the lease duration has expired, the DHCP lease renewal process again begin after 87.5% of the lease duration has expired. We keep trying again and again to try to the contact to DHCP server for the renewal process. If the DHCP client failed to renew its lease after 87 lease expired, the DHCP lease generation process start again and again with the DHCP client and broadcasting the DHCP server. This DHCP client keep trying again and again. First step, it take at the 50% of the time elapse. Second time, 87.5% of the time elapse, it start second attempt. But if still DHCP is unreachable, if it reachable, okay, then IP get renewed, lease time get renewed. But if after the 87.5% of the time elapse and client is not able to contact to DHCP server for the renewal, it starts sending the message again on the network. So if the IP get renewed, okay, your client machine IP get renewed, lease time has been renewed, and it start keep working. But in case DHCP is down due to any reason, then APIPA APIPA stand for IP private IP assignment, automatic private IP assignment. It is range 169.254.0.0 to 169.254.255.255. So it's a window function that provide DHCP auto configurations addressing. So APIPA assign this IP series to the client when DHCP is either permanently or temporarily unavailable. So if client machine is not able to contact DHCP server, so APIPA come into play. Future of DHCP. Hope you understand about the DHCP processing, how to configure DHCP on a Cisco router. Future, this all about I have discussed is about IP version 4. So IP version 6 development and deployments move forward and change the DHCP role significantly. One of the great advantage of IP version 6 is the auto configuration. IP version 6 host can create local IP address using their own hardware address and neighbor discovery process. We will discuss about this process when we discuss the IP version 6 process. In that case I will discuss auto configuration and all the other features of the IP version 6. Some of the simple troubleshooting command. Very simple, ipconfig command to verify the current IP that has been assigned to the client machine. Some another command for the troubleshooting purpose, if case there is some IP confliction and you want to release the older IP and get the new IP, so if we get the command at the CMD prompt that can be ipconfig/release to release the older IP and ipconfig/renew to renew the IP address of the client machine from the DHCP server. So hope you enjoy this video.